In our previous lecture, which was last week, we have discussed about electron configuration. So electron configuration is how we describe electrons in the sub-level or in the orbital. So how do we represent the electron distribution or electron configuration? So you could use this sub-level notation. So this is called sub-level notation. So we have the M, and then the sub-level, the L, and also the number of electron in the orbital. Okay, and we could also represent the electron in the orbital using orbital diagram. Okay, using orbitals diagram. Okay, so we have three principles that governs the occupation of the electron in the orbitals. So we have Aufbau, Hund's rule, and Pauli exclusion principle. So the electron need to occupy the orbital based on these three rules. Okay, all right. So you should know what are the rules and make sure that you are able to define the rule if you are asked to do so. Okay, all right. And then moving on, we have ways to describe electron configuration. Okay, so we have few types of electron configuration. One is known as full electron configuration, which all of the sub-levels are shown. Okay, and then we have partial electron configuration that shows only the highest energy sub-level being filled, which also represent the valence electrons. Okay, and then next we have condensed electron configuration. By condensed, it means compact. Okay, so in order to represent the compactness of the electron configuration, we use previous noble gas. Okay, right. So for example, we have aluminium. So the Z for aluminium's atom is 13. The atomic number is 13. That means we would use neon. Okay, neon for the noble gas, and then we have so neon captures only 10 electrons, so the rest are written as is lah, 3s2 and 3p1. Okay, all right. Okay, we also have orbital diagram. So we have full orbital diagram. Few ways to describe using orbital diagram. So we have full orbital diagram, partial orbital diagram, and condensed orbital diagram. So it depends on the question whether it specify the electron configuration or orbital diagram to be in condensed orbital diagram, for example, or partial electron configuration and whatnot. Okay. All right. So that were covered in our previous lecture. Okay, so next let's move on to our to this slide. Okay, right. So we have learned on how to write the full electron configuration. So we have aluminium, for example, right? So we have learned how to write the full electron configuration. So this is how you write the full electron configuration for aluminium. And then this is a partial electron configuration. So we have 3s2, 3p1. Okay, it displays on only the highest N, highest sub-level being filled. Okay, and then we have condensed electron configuration. So it uses the previous noble gas before the aluminium. Okay, all right. So this is neon, for example. So this is where aluminium is located. So we need to use neon. We cannot use helium, for example. Okay, so it need to be just before the elements is found. And then number of valence electrons. So how do we determine the number of valence electron? Okay, we can determine the number of valence electron from the highest sub-level being filled. Okay, so this is 1s2, 2s2, 2p6, 3s2, 3p1. So first you have to determine the highest sub-level being filled. So this is the highest sub-level being filled. So we have 3P1 based on the n lah, based on the value of n. So the highest will be n is equal to 3. Okay, so what we do next is to total up the number of electron in both sub-level. So 2 plus 1 is equal to 3. So the valence shell has 3 valence electrons. Therefore, these 3 valence electron, okay, represent the group number. So the aluminiums come from group 13. Okay, so the group number correspond to the number of valence electron, and the period number correspond to the principal energy level of the valence electron. Okay, all right, so this is how our periodic table looks like. Okay, as you can see, we have rows, okay, rows, baris, and we also have groups. So this is group 1 to 13, 14, 15, 16, and until 18. Okay, all right. So from the electron configuration, we would know the valence electron, okay, and also the group of the element that it is belong to. Okay, so we have 3 valence electron, therefore it belongs to group 13. Okay, just for your information, okay, these 2 group here is called S block. Okay, we can divide the periodic table based on blocks. So we have S block, and then the block here is called P block, and then we also have D block. Okay, and then we have F block. So we are not going to cover for F block. Okay, for your syllabus, we are going to cover only the main element and also few elements from the D block ataupun transition metal in the D block. Okay, all right. Okay, why is it called S block? Why is it called P block and D block? Okay, so how do we differentiate? How do we determine whether an element come from P block, S block, or D block? Okay, right, senang je. Okay, for example, look at aluminium. Okay, we have aluminium, right? So we refer to the last sub-level being filled. Kita refer pada sub-level yang last kali being filled. In this case, the last sub-level is 3P. P. The P, it ends with P orbitals. That means aluminium come from P block. Okay, that means you can only find aluminium in this P block. And to specify furthermore, okay, we need other information. So we have 3S2, 3P1, kan? Okay, so we know that the, aluminium come from P block, and then we have so many rows there. So which rows ataupun which periods that aluminium is located in? Okay, so the N here, the N here, like what we have here, period number correspond to the principal energy level. Okay, so this represent the period ataupun the principal energy level. So N is equal to 3. Okay, N is equal to 3. So we are going to look for aluminium for principal energy level. N is equal to 3. Okay, right. So N is equal to 3. So definitely not in S block. So this shall not be the location of aluminium. Okay, so dia punya hint dia adalah N is equal to 3, and then it should be in P block. So as you can see, for N is equal to 3 and P block elements, so we have 1, 2, 3, 4, 5, 6. We have 6 possible elements. Okay, and then how do we narrow down from there? So another tips is, okay, ada 2 cara kat situ. Satu cara, based on the the last sub-level being filled. This is the last sub-level being filled, 3p1. That means they start from left to the first element of the P block, which is here. Okay, the first element. Okay, the first element of P block from the left. Okay, so dia ada satu kan, so satu lah. So this is where aluminium is located. If it is 3p2, that means dia duduk dekat sini. 1, 2. Ni. If it's 3p3, that means dia 1, 2, 3. Okay? Alright. Or alternatively, okay, let me erase all the inks first. Or alternatively, so we have 3s2, 3p1, kan? So this is the highest sub-level being filled for aluminium. We could also refer it as S1. So this is S1, S2, okay, and then 3p1. So 3s1, 3s2, 3p1. There you go for your aluminium. Okay, all right. So this is the periodic table actually shows how the electrons are being filled in the for the orbitals. Dia macam afbau, okay? Right, we're gonna start with n is equal to 1. Kan, n sub n is equal to 1, that means 1s. 1, we have 1s saja, s orbital here, so 1s, and then we have 1s2. This is 1s1, this is 1s2. Okay, remember we have hydrogen here, and then we have lithium, beryllium, kan? So 1s1, 1s2, and then come back to lithium, n is equal to 2, okay? And then here we have 2s1, this is 2s2, okay? Penuh, masuk dekat P pula, 2, this is 2p1, this is 2p2, 2p3, 2p4, 2p5, 2p6, dah penuh all of this, come back to block S again, n is equal to 3. So this is 3s1, 3s2, okay, and then 3p1. Nampak tak, sama? It's like what we have in the electron configuration. Okay, so that is how we can determine the location of the elements in the periodic table. So the electron configuration gives us information on the location of the element in the periodic table. Okay, all right. So this is S block. If it's from S block, that means dia punya electron configuration should ends with S sublevel. Okay, S orbital. For example, lithium. Lithium we have 3, kan? The Z, the atomic number for lithium is 3. So how do we write the electron configuration for lithium? It is 1s2, 1s2, and 2s1. Okay, so lithium can only be found in S block. Same goes to beryllium, because beryllium, the Z number is equal to 4, right? So it is 1s2, 2s2. Okay, and then we have D block. D block means the last orbital will be the D orbital. Okay, and same goes to P block. That means the last orbital being filled will be the P orbitals. Okay, it is very interesting to know how the elements are being arranged in the periodic table. Okay, write the full and condensed electron configuration and draw partial orbital diagram for the following elements. Okay guys, please, I give you 2 minutes to complete this one, or have you completed this checkpoint before? Maybe during our last lecture last time, I have reminded you to complete the checkpoints.
No.
Not yet. Okay, I give you 2 minutes. Okay, please complete this checkpoint now. Three minutes. So there are 3 things that you have to address in this question. Full, okay, write the full condensed electron configuration, and also draw the partial orbital diagram for the following elements. Okay. All right. Okay, so let's discuss for A first. Okay, magnesium. Write the full and condensed electron configuration and draw partial orbital diagram for the following elements. So we have um, we need to write the full electron configuration and then the condensed. Okay, so for the full electron configuration, we have the number of electron is equal to 12 because we are talking about atom now. Okay, all right. So for full electron configuration, it should be 1s2. Okay, if you are still not used to the sub levels ataupun the orbitals, okay, you need to use the aufbau. Okay, the aufbau yang tangga tu, staircase tu, 1s, 2s, 2p, 3s, 3p, 3d, okay, 4s, 4p, 4d, and 4f, and 5s, 5p, 5d, 5f, and so on. Okay, so use arrow, diagonal arrow, okay, to make sure that to guide you, okay, to guide you on, ni terlajak sikit ni, to guide you on how to place the electron in the orbitals. Okay, so 2p, 3s, and then we have 3p, 4s, okay, and then 3d, 4p, 5s. Okay, all right. So 1s2, and then we have next will be 2s2. Okay, and then after 2s2 we have 2p6. Okay, 1s2 and then 2s2, and then next will be 2p6. Okay, fully occupied. So we have 10 already. Next we need two more. Okay, we need to place two more electrons. So we need to apa nama tu, buka new orbital here. So next will be 3s2. Okay, so make sure that in total you should have 12 electron. Okay, all right. So for the condensed, the condensed electron, for condensed electron configuration, we need to use the noble gas. Okay, the noble gas just before magnesium. So what would it be?
Neon.
Okay. So neon covers 10 electron. Okay, so we have neon, and then we have 3s2. Right? So maybe you can prepare also for partial electron configuration, just to practice yourself, okay, to familiarize yourself with the type of electron configuration that could be asked in the exam. Okay, so if the question is asking for partial, but you instead you give full electron configuration, even though it is correct, sorry, it will be wrong. Okay, no marks will be given. You should address the question. Okay, so partial will be, remember, what does it mean by partial? Partial only displays the highest sub-level being filled, the highest energy sub-level being filled, which is 3s2. So the answer would be 3s2 only. Okay, all right. So same goes to orbital diagram for full orbit. So the question is asking for partial orbital diagram. We have the partial electron configuration already. So the partial orbital diagram will be 3s. Okay, and then we have 2 electrons in the orbital. So this is how the partial orbital diagram looks like. Please, 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 again, I remind you again. Okay, do not include the subscript for the orbital diagram. Okay, do not do this. Jangan buat macam tu. Okay, so to represent the number of electron, we have drawn the orbital diagram, and in it we have 2 electrons. So why do we need that redundancy? Tak perlu redundant. So tak payah dua tu. Okay, so electron configuration is this, the partial electron configuration, and this is the partial orbital diagram. Okay, right. Same goes to phosphorus. Sama saja for phosphorus. Kita ada additional 3 electron there. So 1s2, 2s2, 2p6, 3s2, 3p3. Okay, alright. So from here kita boleh, there are a lot of information that we can obtain from the electron configuration. So we would know in the periodic table, the phosphorus is located at period number 3, okay, because it is the highest sub-level, the highest principal energy level. It has, the highest principal energy level is equal to 3. Okay, and then the group for phosphorus, okay, we can total up this 2 plus 3 would be group 15, or it has 5 valence electron. And phosphorus can be located in the P block. Okay, so banyak information that we can obtain from the electron configuration itself. Okay, same goes to magnesium just now. Okay, alright, so for the condense, sama juga, okay, for the condense, as you can see, both of them come from the same period. Okay, n is equal to 3, maksudnya dia duduk dekat period 3, row number 3 in the periodic table. Okay, alright, that means the noble gas used is the same, which is neon. Okay, for phosphorus, we have 3s2, 3p3. Okay, and for the partial, so partial will only include the highest energy sub-level being filled, which is 3s2, 3p3. Okay, for the partial orbital diagram, it will be 2, 3. 1, 2, 1, 2, 3. Okay, this is based on Hans' rule. Okay, you should occupy the orbital singly. Okay, and then once it is full, then only you can start pairing up. Okay, right. So yeah, this is how you answer the question. Okay, any questions so far, guys? Okay, good. Are you guys doing okay there? So far, so good.
Okay.
Okay, madam.
Okay, dia very interesting. Kalau you faham, memang seronok lah. Kalau tak, you memang ngantuk. Okay, alright. Let's move on. Dan dia banyak cakap lah. Saya banyak cakap dalam topik ni. Okay, so letih sikit lah kat situ. Classification of electron. So there are 2 types of electron. So we have valence electron and also core electron. So valence, okay, as we know, valence, apa nama tu, electrons that are that occupy the highest energy shell. Okay, ataupun the outermost. The valence means outermost. Okay, so it is they are located at the outermost shell. Maksudnya shell yang paling luar. So how do we identify the outermost shell? So by right, it should have the highest energy shell. Okay, like phosphorus just now, the highest energy shell will be 3s, 3 lah. N is equal to 3. Okay, that means the valence electrons are located at N is equal to 3. Okay, so that would be your valence. So opposite to valence, we have inner lah. Okay, valence mean outermost. Opposite to valence, we have inner electron or core electron. Okay, right. So electron in lower energy shells are called core or inner electrons. Okay, as you can see, so this is a diagram to simplify, okay, to explain how we can differentiate between valence and the core electron. Okay, so senang, yang warna hijau, the green one represent the valence. Nampak tak dia dekat outermost shell. The core would be the one that the electrons that reside in the inner shell. Okay, N is equal to 1. So what do we have just now? Phosphorus kan, 1s2, 2s2, 2p6, 3s2, 3p3. So once we have identified this is the valence electron, the rest are all core electrons. So if the question is asking for the number of core electron for phosphorus, so identify the valence electron first. Okay, so once you do that, okay, the rest will be the core electron. So 6 plus 2 plus 2 is equal to 10 electrons. So there are 10 core electron for phosphorus. Okay, so one of the most important factors in the way an atom behave chemically and physically is the number of valence electron. So the number of valence electrons can determine the behavior of atoms. Okay, either chemically or physically. Okay, all right. So phosphorus again. So we did that. We did this before. So this is the full electron configuration. This is a condensed electron configuration. Okay. So basically, once we have identified the valence electron, so the rest will be core electron. Same goes to calcium. Okay. Identify the highest N first. Okay. So these two. Okay, and others element in the periodic table that come from main group element. Main group elements such as group 1, group 2, 13, 14, 15, 16, 17, and 18. Those are all main group element. Okay, main group elements, that means it will be based on the highest sub-level, the highest sub-level being filled. Okay, which is in this case phosphorus, N is equal to 3. For calcium, it is N is equal to 4. Okay, so this is the highest sub-level. We have 2 electrons in, N is equal to 4, then the rest will be core electrons. So in total, we have 18 electrons. So this can also be written in condensed form. So we can use argon to represent the 18 electron. Okay, all right. So this is a special, okay, for transition element. Okay, transition element is always special. Okay, dia ada lain sikit. Dia ada sedikit tambahan dekat situ. Okay, remember, like I said, this one just now, they come from main group element, group utama in the periodic table, kan? And then we also have transition element. Okay, so transition element, we have 25 electron. Okay, macam biasa. This is an example, manganese. So we have 25 electrons. So like I mentioned earlier, so how do we know the location of manganese in the periodic table? Senang saja, okay. Look for ataupun refer to the last sub-level atau the last orbital being filled. In this case, d orbital. So that the d orbital. This one S, maksudnya we will look for calcium in S block. Okay, so manganese the electron configuration ends with D. That means dia duduk dekat D block. Okay, alright. Tapi apa yang special pasal transition element ni? Okay, the group number. Okay, the group number dia kena total of 4s and 3d. Yes. Okay, it should be a total of 4s and 3d. Okay, so the valence electron is 5 plus 2 is equal to 7 valence electron. Okay, and the core electron will be the total of this lah. Okay, 6 plus 2 plus 6 plus 2 plus 2 which equal to 18. Okay, itu saja tambahan dia. That means you have to be alert that for transition element, okay, how do we know that it is transition element? Okay, based on, tengok dia punya tips dia adalah bila you buat electron configuration, tengok dia ends with D orbital or not. If it's end with D orbital, like what we have for manganese, that means dia adalah transition element. Tips number 1. Okay, so dia ends with D orbital. That means dia adalah transition element. So if it's transition elements, to determine the number of valence electron, dia special sikit. You kena total up the S and the D orbital. Okay, so it is 5 plus 2 is equal to 7 valence electron, and manganese come from group 7. Okay, group 7. So this is a condensed electron configuration for manganese. Okay, alright. So don't get confused. Okay, contohnya katakanlah soalan we have electron configuration as this one, 4s2, 3d10, and 4p3. Okay, 4p3. Is this element having this electron configuration? So we have the lower sublevel. Okay, so is this element considered as transition element? Guys, is this element considered as transition element?
No.
Okay, very good. Okay, this is not considered as transition element. Lagi sekali, transition elements dia mesti stop dekat D. Okay, this is not transition element. Even though you nampak sini ada D, dia bukan transition element sebab dia dah ada P dekat situ. Okay, so to know the group ataupun the valence electron for this element, you kena ambil the highest end. Okay, because this is main group elements. So you have to total 2 plus 3. So the highest end is equal to 4. Okay, so the valence electron is 5 electron. Faham tak? Maksudnya kalau kita nak, if we were to imagine lah kan, maksudnya alamak, nampak tak predictable this one. So clearkan. Okay, alright, so dia akan masuk 1S, 1S1, 1S2, and then 2S1, 2S2, and then 2P6, tapi masuk 3 pula, 3S1, 3S2, 3P1, 3P2, 3P6 penuh, and then masuk pula 4S1, 4S2. Okay, 4S1, 4S2, and then dia dekat blok P kan, 4P3 tadi yang saya tak silap saya tulis. This one, 4S2, 3D10. Maksudnya, this means that in order to reach to this location 4P3, dia kena lalu D tu. Okay, 3D1, 3D2, 3D3, 3D4 until 3D10. Lepas tu baru 4P1, 4P2, 4P3. Okay, tapi dia still duduk dekat P, block P. Okay, block P, and the valence electrons in total will be 5. Group 50. Okay, so jangan nampak bila ada D je, oh ni transition element ni. Not necessarily. Okay, you have to observe whether the D orbitals are fully filled ataupun dia partially filled. For transition element, dia partially filled saja. partially filled, then only we can call that element as transition elements. Okay, all right. So please ingat, for transition element, it is special, then you have to consider the S and the D, okay, for the total number of valence electron. Okay, all right.
Madam,
Yep.
yang untuk tadi tu kan, kenapa tak ambil 4S2 tu je? Sebab kan tengok dekat end, the highest end kan? Kenapa
For
kena ambil yang
manganese just
3
now,
tu?
this one that's why saya kata dia special. Dia transition element. Okay, we have to consider for 4S2 and 3D5. Okay, the reason kejap lagi kita akan tahu. Kenapa kita kena consider for the D orbital as well. Okay, remember kalau if in our previous lecture last time regarding Aufbau, okay, the location, the 4S and 3D, okay, the orbitals are closer. Okay, dia punya gap is not much of different. Okay, so that means the D orbital ataupun the S orbital, okay, they are closer to the D orbital. S is closer to the D orbital. That means the electron from the S orbital can be promoted. Dia boleh jump into the D orbital. So that is how close they are. Faham tak? So bila dia boleh lompat, dia ada that probability to jump from the S orbital to D orbital. It shows that the gap, the energy gap is not big. Okay, dia tak large. So that's why for transition element, one of the reason is kenapa we have to include S dengan D, okay, because the gap, okay, the energy gap is not much of a different. Okay, so which is so we have this in this slide. Okay. Ni baru nak introduce lah, tapi saya dah cakap awal dah kat sini so that you dah ada that information and then kita repeat again, you become more clearer. Okay, alright. Okay, this is for transition elements. Tadi saya dah explain early. Okay, so hopefully bila cakap lagi sekali you dapat that idea lah. Okay, transition element. The highest principal energy level is 1 less than the period number. Okay, what does it mean by this? Okay, later kita akan tunjuk the D orbital tu, it should be less 1 than the principal energy level. Okay, you may have noticed in the Aufbau, so we have 4S and then kita akan 3D, betul tak? 4S2 and then 3D something. So this is what it meant. Maksudnya the first D orbital tu would be 1 less than the principal energy level. Okay, yang sepatutnya. So sometimes an S electron is promoted to the D sub level. Due to what? Due to the orbital overlapping resulting in smaller energy difference. Okay, the reason they boleh promoted because sometimes they can overlap, okay, due to the small energy difference. Okay. Okay, for example, scandium. Okay, how do we know that this scandium? Okay, scandium is a transition element because when we write the electron configuration, it ends with D orbital. Okay, so 4s2 3d1. So this is a condensed form. Okay, 4s2 3d1. So how do we write the orbital diagram for scandium? So we have 4s2 and then 3d1. Okay, all right. So the period. Okay, the period that scandium is located in is in period 4. Period 4. Okay, tapi dia group 3. Dia group 3 because dia ada apa nama tu 3D1 kan, maksudnya block D tu. Okay, dia yang first. This is 3D1. Okay, this is 3D1. Tapi kalau kita start from the beginning, that means dia group 3. Sebab kita ada 4s2 tadi. 4s2, 1, 2, 3. So that's why dia group 3. Okay. This is example. Okay, ini abaikannya. F ni patutnya dia duduk dekat bawah. Okay, alright. So this is the S block, this is the D block, and then we have the P block. Okay, kat sini, the highest principal energy level is 1 less than the period number. So this would be our period number, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Okay, n is equal to 1, we do not have the D block. Okay, yet kita tak ada, nampak tak? Tak ada D block. So n is equal to 3, okay, we do not have the D block still. Okay, tak start lagi pun, transition element start dekat n is equal to 4. Bila n is equal to 4, we have 4s, right? But for the d orbital, kita dah start ada d orbital. So the d orbital will start with 3d, not 4d. Itu yang maksud dia, principal energy level is 1 less than the period number. So the period number is 4, n is equal to 4, but the d orbital will start with 3d. Okay, so if n is equal to 4, that means we have 3d. If n is equal to 5, that means we have 4d. N is equal to 6, we have 5d. N is equal to 7, we have 6d. Okay, again, this is the same as what we have in AFPAO, right? So we are going to occupy the 4s first, and then we have the d orbital. Okay. This one. Okay, 4s sublevel is lower in energy than the 3D. So 4s, we have 4s and then we have 3D. Okay, 4s has lower energy in terms of energy. We are talking about energy. 4s has lower energy than the 3D. Okay, but that is why the 4s is being filled first before the 3D, because it has lower energy than the 3D. However, the gap between these two orbitals are not that large. Dia tak besar pun, dia sikit. Okay, sometimes the electron from 4s can be promoted into the d orbital. Okay, sometimes. I think that is because one of the reason why for transition element, okay, special transition element, you have to include the s and the d orbital in order to determine the group number and also the valence electron. Okay, so kena ingatlah sekarang, maksudnya ada dua kategori. So one would be the main group element. Senang je, the main group element we will be based on the highest n. Totalkan the electron in the highest n. Okay, but for transition element, we have to total up the s, which is the highest kononnya, n is equal to 4, kan? Which is s, and then the d orbital too. Okay, kena consider s and d orbital. Yeah, alright, so far so good. Are you guys doing okay? Before we go for anomalous, anomalous mean abnormality. Ada abnormality in the electron configuration. So that is called anomalous. Okay ke so far?
Okay.
Alright.
Okay.
Alhamdulillah. Okay, transition element again. Okay, kena ingat transition element is special sikit. So for the transition element, we have anomalous. Anomalous means maybe you are more familiar with abnormality. Okay, abnormality. So abnormality come from the word abnormal. Maksudnya dia tak follow the normal trend. Okay, this special because it does not follow the normal trend. So that is the general term for abnormality. So in chemistry, we call this abnormality, the species or whatsoever is can be called as anomalous. Okay, anomaly or anomalous. Okay, some of the transition metal, again the transition metal ni yang selalu buat hal sikit transition metal have irregular, same as abnormality, okay, have irregular electron configuration in which the ns, the s orbital, only partially fills before the n-1d or doesn't fill at all. Okay, this is because, kenapa this is so? Because this electron configuration has extra stability associated with half-filled or completely filled subshell. Okay, so how it is being filled in the orbitals also affects the stability of the orbitals. Okay, remember Hans last time, kenapa kita kena fill up secara singly with similar spin before we can start pairing up. Okay, remember I was talking about the half-fill orbital. Okay, half-fill is considered very stable for an orbital. Okay, alright. This is for anomalous, but before we go into the example that we have here, okay, just to highlight to you what does it mean by orbital stability. Okay, alright, so for an orbital, for orbitals to be stable, okay, for orbitals to be stable, it can be in the form of half-filled or completely filled subshell. Okay, let's pick one orbital. So let's have p orbitals. So we know that p orbitals has 3 orbitals kan. P-shaped orbital has 3 orbitals in it. So let's say katakanlah we have 3p lah. This is 3p. Example 3p. Okay. In order for a 3p orbital to become stable, ada 3 cara. Satu, there is no electron at all. Okay, bila tak ada electron, that means there's no repulsion kan, tak ada repulsion, then basically there's nothing lah in the orbital, so that means the energy would be lower. Okay, alright, so this is the first one, there's no electron, it is stable. Alternatively, it can also be stable if it is half-filled. Half-filled means terisi secara separuh, bukan sebahagian, separuh. So 1, 2, 3. So this is half-filled, and they by right they should have the same ms spin. Spin dia mesti sama lah, positive half, positive half, positive half. Okay, this is based on Hans rule. Okay, so this is another condition that the orbital is in stable form. Okay. Alternatively, so this is half-filled or completely filled subshell. Completely filled subshell maksudnya dia macam ni. 1, 2, 3, 4, 5, 6. Okay, this is also considered as stable. Okay, so this is for p orbital. So for s orbital, dia dalam keadaan macam mana pun dia tetap stable sebab s has only 1 orbital kan, betul tak? So this is kalau dia kosong, 3s. This is kalau dia half-filled, betul tak? This sebab dia ada 1 orbital saja. This is kalau dia full-filled. So either 3 pun, 3 pun dia stable, but it only has 1 orbital. Alright, so how about d orbital? Yang dekat sini yang transition element. Okay, it is abnormal because of the d orbital tadi. Okay, in order for the d orbital to become stable, samalah. Okay, cumanya that the d orbital now has 5 orbitals in it. Okay, right. So d, we know that d orbital, for d-shaped orbital we have 5 of them. So this is 3d for example. So it can be no electron at all, or it can also be half-filled. This is how the d orbital looks like if it is half-filled. Okay, maksudnya we have 1 electron in each orbital with the same spin, similar spin. Okay, so this is stable, and the last stable form of d orbital would be full-filled. Okay, alright. Stable, stable, stable. That means other than these 3, okay, dia tak stable. Contohnya begini. This is not stable. Okay, this is what we call partially filled. Partially filled, terisi sebahagian. Okay, this is also not stable. This is also not stable. This is not stable. Okay, this is stable. So ini dah half filled. But this one tak stable balik, tak stable, unstable, unstable. Okay, and this one stable. Dia dah full filled. Right? So we have to consider this extra stability of the orbital. Okay, so based on this understanding, cuba kita tengok example of transition element that has this abnormality ataupun what we call as anomalous. Okay, for example, we have chromium. Kalau chromium, we have chromium and copper. Okay, so now let's look at for chromium first. For chromium, the Z for chromium will be 18 tambah 4 tambah 2. Berapa guys? 24 24 kan? Alright, so if we are based on this number of electron, kita based on afbau, kita buat macam afbau, kita akan dapat this electron configuration. Betul tak? Kalau kita based on afbau, the three principles that we have for before we can write the electron configuration. So this is how we are going to write the electron configuration for chromium. That's why dia panggil expected. Sebab kalau kita based on afbau, this is what we are going to have for the electron configuration untuk chromium. But this is not the case. In reality, dia bukan macam ni rupa-rupanya. Dia macam ini. Okay, dia 4s1 and 3d5. Again, kenapa 4s1, 3d5? Because kalau 3d4, dia initially macam ni kalau saya nak tunjuk kat mana Okay, dia 4s, this is 4s, 3d4. This is expected one. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 1, 2, 3, 4. Ni expected one. Kalau based on afbau, tanpa kita fikir pasal extra stability ke whatsoever. Okay, this is what we expect. But sebenarnya this is how the orbital for chromium looks like. Okay, 3D. Dia sebenarnya begini. Okay, so obviously one of the electron from 4s is now being promoted into 3D orbital and becoming this. Okay, kenapa again? Due to dia nak achieve the stability. Okay, 4s is not a problem because either condition pun it will still stable. But 3D, we know that 3D has higher energy, right? Compared to 4s, D orbital itself is very high in energy. So we need to stabilize the D orbital if it is possible. Bukan every time pun kena lompat tak semestinya, kena tengok keadaan pada ketika tu. Boleh lompat dan dia stable tak? If dia lompat but still tak ada stability, then what's the point nak lompat? What's the point to transfer the electron to the D orbital? Okay, so dia lompat and then they become this half filled. That means this is better than the expected one. Alright, so that's why sebenarnya dia bukan macam ni, it should be like this. So you kena consider lah, abnormality ni selalu dia special. Okay, kita nak make sure that student betul-betul ingat, that means the probability to be asked in the exam is high. Okay, same goes to copper. So copper pun sama for S2, 3D9, this is what we expect. Okay, based on copper's punya atomic number, but it is not like this. Instead, it is this. Okay, this is how the electron configuration should be written. So it should be 1, 2, 3, 4, 5. Okay, this is 4s, 3d. So 1. Okay, so initially dia macam ini. Kalau expected, this is how it looks like. Okay, 4s2. 4s2, 3d9. Okay, this is unstable. So to stabilize the d orbital, so one of the electron need to be promoted. Okay, and then dia jadi macam tu. So there should be no electron here in the 4s, tapi kita ada yang this one. Dah promote. Okay, so this is stable. 4s is stable now, 3d is also stable. Okay, alright. So kena ingat anomalous for for what we call for transition metal. So far in your syllabus, we are going to have these two only. Last time we used to have more than this. Okay, we used to have more than this. Ada banyak sebab transition metal itself dia ada banyak kan, ada berapa? Ada empat row for the transition elements. But the one that is covered in our syllabus is only these two sahaja. Takkan tak boleh ingat. Okay, so we have chromium, copper. In the transition element itself ada banyak anomaly dekat situ, but we are only covering for chromium and copper. Okay, alright. So please take note on this. So you have to be careful. Obviously lah, soalan takkan bagi chromium. Maybe instead of chromium dia akan bagi X. Okay, but dia bagi the Z number 24. It means you have to be very careful in order to write the electron configuration. Okay, when you saw this kind of expected, that means, oh, okay. Okay, slow down. Oh, this is not how it is supposed to be. So it should be transformed into this. Tak apa, you start off with expected, it's not a problem. But you should end with this half fill or full subshell. Nak start tak apa daripada expected. Tapi kena tunjuk that this is the final electron configuration. Okay. Okay, ini adalah contoh-contoh. These are the examples for elements in the periodic table. Okay, maybe you can try out on your own saja nak practice how to write the partial orbital diagram for sodium, and then the full electron configuration and the condense. Okay, alright. So as you can see, so 3S, 3P. Kenapa dia 3P? Kenapa dia aluminium, silicon, phosphorus and argon? These elements considered as block P element because they ends with P orbital. Nampak tak? P orbital, P orbital, P orbital. So these two come from S block element. Apa ni? Eja apa ni? Element. Okay, element. Alright. So potassium is also come from S block element. Okay, calcium 2, scandium, titanium, vanadium, chromium, manganese. Okay, so these are all transition elements. Sorry, start daripada sini. Okay, these are all transition elements. Kenapa? Because dia ends with D orbital. See? D orbital, D orbital, D orbital, D orbital, D orbital. Okay, just be careful. For chromium, nampak tak dekat sini, dia special sikit than the rest of the group. The rest of the, element. Okay, so take note for chromium and copper. Anomaly, okay? Right, okay, write the full electron configuration for the transition element, guys.
Madam.
Yep.
Untuk yang slide sebelum ni, yang manganese tu, dia punya manganese, bukan?
This one,
Yang betul-betul sebelum tadi.
This one.
Bukan, yang lagi.
Before.
Betul-betul before yang checkpoint yang Radha nak tunjuk tadi.
Checkpoint.
Yang ni. Yang sebelah tadi kejap.
This one.
Sorry, ini salah. Manganese tu untuk yang condense 4s2 3d6 ke ataupun 4s2 3d5?
Manganese. Manganese, the atomic number is 25, right? So it should be 4s2 3d5. 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 Okay. Manganese tak ada masalah sebab dia memang this is stable form of electron configuration lah. Okay. This is almost the same as, bukan tak sama pun, macam copper punya style kan. Copper dia kena lompat kan. Ini memang as is. Dia memang secara asalnya dia cukup 2 kat sini, kebetulan dia pun ada 5 dekat dalam tu. Tak payah promote apa.
Sebab yang dia tulis tu 3d6, so macam confuse sikit.
Oh, mana. Sini 4s2 1 2 3. Ya ke? Okay, jap. Ya, salah lah ni. Tak boleh.
Thank you, madam.
This is 18, 19, 20, 1, 2, 3, 24, 25. Ya, betul. So di 18, 19, 20, ni dah terlebih, ni dah jadi 26 ni. So it should be 3D5. Okay? Okay, thank you for highlighting this. Okay, the rest please make sure that you correct ataupun amend your notes. It should be 3D5. Okay, 3D5. So don't worry, you buat sendiri and then you notice ini macam salah ni. Most likely dia adalah typo lah. Okay, so tak semestinya lecture notes semua ni betul ya. That's why you kena highlight kalau you notice any apa nama tu pelik ke, okay, ataupun kesalahan, please let me know. Okay, cuba buat untuk, nak buat untuk apa? Cuba buat titanium and chromium and copper. Basically we have in the previous slide already kan. Maybe we can test out for titanium and copper. Okay, titanium and copper. Boleh try buat. Okay, maybe for this time around, I can call up names, okay, for you to read out your electron configuration. Okay, maybe ada yang dah ngantuk, tersengguk-sengguk ataupun tak buat langsung, relax je kan. Madam cakap suruh buat tapi dia tak buat. Okay, tak apa. Kita panggil Okay. Make sure guys, bila saya suruh buat tu you buat. Okay, this is not for me, this is for you. Okay, the more you practice by right, the more you familiar, the more you remember. Kalau you tak nak buat, saya tak boleh paksa. Okay, tapi kena buat lah. Kena. You kena use all your senses. Okay, you punya motor cycle. Okay, motor apa tu? Motor sensory punya ni kan. Gunakan. Lihat, dengar, rasa, pegang apa benda semua tu. The more you combine all the sensor tu, lagi senang you ingat. Okay, this is scientific proven bukannya saya saja buat macam tu. Sometimes kita dengar, oh faham. Tapi bila when it comes to you nak practice, nak buat, dia macam tak link. Sebab dia tak ada memory. Okay, you punya tangan dia tak ada memory untuk you buat the electron configuration. That's why bila apa-apa dengar ke conteng. So nanti dia akan ada that you tak sedar tapi dia ada. Okay, dia ada di situ duduk menyorok. Nanti bila kita panggil slowly nanti it helps. Somehow it helps. Okay? Right, so let's have siapa? Kita pilih Zarifah lah. Nur Zarifah. Okay, Zarifah, for titanium, maybe you can read out your answer. The rest please check. Oh, nak buka pula ni. Wait, sorry Okay, so alright, Zarifah, what's your answer for E?
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2.
Okay, 3D2. So this is based on Zarifah. Okay, do you guys agree with her answer?
Yes.
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 Kena check setiap satu. So kita examiners, kita akan check you total ni betul tak? Tak, dia equal to 22. So imagine lah kalau ada 120 script, so 120 orang saya kena check for each one of them. Untuk all the sub levels, tau? Okay, and then okay, good. Again, you boleh practice, okay? This is only full electron configuration. You can also practice for partial orbital diagram, partial electron configuration. So for partial electron configuration, it will be partial electron configuration. Let's have Shahid. Shahid, what will be the partial electron configuration for titanium? Partial electron configuration. So this is the full electron configuration. How about the partial electron configuration for titanium?
Sekejap random nak tengok predict table.
Predict table, you have this electron configuration already in the slides kan? Saya dah tunjuk.
Partial, okay.
Partial lah.
3D2.
Sorry?
3D2.
Ini tak
condense
dengar
tadi.
lah. Sorry?
Ingat condense tadi.
Partial orbital. And then, is it 3D2 guys? Remember last time saya dah cakap kan, for transition element it is special. You have to include the highest, not only the highest, you have to include the D as well, the S and the D. Okay, partial maksudnya apa? The highest N kan, the highest N. But this is transition element. For transition element, we have to consider the S and the D. Syahid?
Okay, madam.
So it should be?
For S2, 3D2.
Yes. Okay, so it should be 4s2, 3d2. If you were to draw the orbital diagram, then it should be 1, 2, 3, 4, 5, 4s2. Okay, this is 4s, this is lajak. Okay. Alright, so 3d2. So practice. Remember for please. Transition element is special sikit. In order to determine the valence electron, you kena total out 4s and 3d. For partial orbital diagram too, okay, we have to consider the 4s and the 3d, the s and the d orbital for the partial orbital diagram. Okay, alright.
Madam, yang tu tak stabil kan?
This is considered unstable lah, but itu je banyak elektron yang dia boleh ada. Dia tak boleh buat apa. Even though you promote this one kepada sini, still tak stable juga.
Okay.
Madam,
okay.
saya ada soalan.
You.
Kalau S20, D25 tu stable ke?
Kita ada that possibility. Ada dia for palladium ke apa. Tapi kita dah remove from our syllabus. Okay, ada that possibility yang both of the electron being promoted into the D orbital. Okay, ada. Tak silap saya untuk siapa palladium ke apa, nanti boleh check lah. Dia tak semua yang applicable tau for this. Sometimes kita rasa dia boleh lompat masuk dua-dua, tapi it does not happen that way lah. Dia tak jadi macam tu. Dia ada other reasons yang we have to consider. Okay, so that's why untuk your syllabus saja, as of now kita go for chromium and copper. Tapi last time kita memang ada that possibility. Dua-dua lompat pun possible juga. and then the s orbital become kosong kan. Ada? Okay? So as of now kita just stick kepada chromium and copper. If you would like to know more, then maybe you can carilah, boleh baca, okay, further on this. Alright. Apa tadi? And then copper tak apalah. Okay, copper kita ada example in the previous slide, okay, before this. Okay, so this is how the full electron configuration kan, the full electron configuration for titanium, chromium and copper. Okay, so we also have the what do we call this, condensed electron configuration for each one of them. Okay. Any questions so far? Okay ke?
Okay.
Okay, tak ada question Okay, saya proceed. Okay, so classification of elements into SPD, F block in the periodic table. So this is what I was mentioned to you just now in the earlier slide yang masa aluminium tu sepatutnya saya kena cerita kat sini, tapi saya cerita dah awal. So as you can see, you dah ada that idea. So bila kita go through this slide, you lebih faham. Okay, alright. So kita abaikan the F So kita fill up based on the afbau kan. Kita penuhkan the 1s1 and 1s2 and then baru masuk 2s1, 2s2. Okay, and then 2p1, 2p2, 2p3, 2p4, 2p5, 2p6 penuhkan, then only we go for 3s1, 3s2. Okay, and then 3p1, 3p2 and so on. So this is how the orbitals are being filled. Okay, with electron. So we can get this information from the periodic table. So the periodic table is arranged based on the electron configuration, guys. Dia bukan suka-suka je dia arrange dia macam tu So those yang based on group kan, group tu maksudnya dia group 1. Kenapa dia group 1? Because all the valence electron in the group, okay, all the valence electron in the group, they have the same valence electron, which is 1. Group 1 sebab dia ada satu valence electron. Tak percaya, you go check for all the group 1 punya family elements. You akan end up dia punya valence electron as equal to 1. Same goes to 2, okay, 3, 13, 14, 15, 16, 17 and 18. Okay, so that is how they groupkan the elements in the periodic table. So basically we have period is the N, principal energy level, and then we have the group, group going down. Group represent the valence electron, period represent the N, the value of N, okay, ataupun the principal energy level. Okay, alright. Okay, an atom X has 15 electrons without consulting a periodic table. Please identify what element is X. Okay, what is X? So identify what would be X. Right, so let's have Patricia. Patricia?
Yes.
Okay. Right. Write the full electron configuration of atom X. So what would be the electron configuration for X? Can you please read out your electron configuration for me? Trisha?
Yes. Wait.
So atom X is
The full electron configuration first, okay?
okay.
Patricia, I cannot hear you. Patricia, are you there? Tak okey ke? Apa nama ni mic? Oh, Patricia.
Oh yeah.
Lupa nak on mic ke apa?
Uh-uh.
Okay, so read out your full electron configuration for atom X.
1s2,
Okay,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
so 6, and then 3p6,
3p6. Is it? 3p6?
3s2, 3s2, 3p3.
3p3. Okay, alright. So you have to make sure that the total number of electrons should be equal to 15 electrons. Jangan terlajak, jangan nak penuhkan orbital je. Dia kena based on the number of electrons. Okay, so in total you should have 15 electrons in the sub levels, in all the sub levels in total combined. Alright, okay, so let's have someone else to identify the position of X in the periodic table. So basically what we want to know is, okay, tak apa. Kita panggil dulu orang. Syahira Saleh, Nur Syahira Saleh.
Yes, madam.
Syahira, okay. Alright, so what will be the N? Okay, what will be the N ataupun the principal energy level for X? Or the period for X?
3.
Okay, so N is located at period 3. N or period It's located at period 3. And then how about the group?
The group 13.
Okay, the group is equal to 13. And then how do you know so?
From 3p3.
3p3?
The electron valence.
Okay, so the valence electrons, we have 3 electrons there. Okay, so the group come from group 13 or 15?
13.
13? Are you sure it's 13? How do we determine the valence electron in the first place?
Adding up the number 3s2 and 3p3.
Yes. Okay, so what will be the total for that?
5.
5. Therefore, what will be the group?
15.
Yeah. Okay, so the number of valence electron is equal to 5 electron. So this number of valence electron is equal to the group. Okay, if it has 5 electron, that means the group should be group 15. Okay, so jangan confuse again. Do not confuse on how you locate the X ataupun the elements in the periodic table. Nak locate tu ada banyak cara. Satu, kita boleh kira daripada S, 2 tambah 3. 1, 2, 3, 4, 5. So 2 plus 3 will be 5. Ataupun we can locate from the P block itself. Okay, starting from the left, 1, 2, 3. Okay, so ada beberapa cara dekat situ, but do not get confused, okay, on how to determine the group ataupun the valence electron dengan how to locate the electron in the periodic table. Okay, alright. So the X come from period 3, Okay, and then the group should be group 15. Macam ni lah kalau kita nak pakai ni kan. Okay. So come from group period 3. So period 3 kita ada 3S and 3P kat sini kan. Tapi dia highlighted tadi last sekali the orbital will be P orbital kan. So S dah definitely bukan lah. So dia ada dekat sini. Okay, ni ada banyak ni 1, 2, 3, 4, 5, 6. Which one represent the X? So dekat situ ada beberapa cara. 3P3 kan tadi kan. So this is 3P1, 3P2, 3P3. Okay, and this is how to locate, but that does not represent the group. Group dia adalah you kena total up the highest end. The total up the electron in the highest end. So dia ada 3s2 tadi kan. So 3s2, 2 plus 3 would be 5. 5 valence electron equal to group 15. Okay, jangan confuse dengan tu. You kena betul-betul faham dengan. Alright. Okay. Any question?
Madam. So untuk soalan yang B tadi, saya nak tengok cara tulis tu.
Itulah. Period is equal to 3, group 15, block P. Sampai you boleh narrow down the location, the coordinate of the X in the periodic table. Okay, so whatever information yang you ada, you bagilah. Right.
Okay, thank you madam.
Okay, so that one is for atom. Okay, atom for main and group, atoms for transition element. Okay, next we are going to be talking about ions. Atoms are done. Kita dah discuss atom just now. Okay, based on the electron configuration, how do we locate the elements in the periodic table, and then how do we determine the groups? How do we determine the period? Okay, how do we determine the valence electron, the core electron, and whatnot? Okay, alright. So now is ion. How do we, basically sama je, cumanya for ions, electron has been gained and electron has been removed dekat situ. Itu sahaja. Okay, alright. Representative element. What does it mean by representative element? Maksudnya elements that come from main group lah, main group element. That is what we call representative elements. Group 1, 2, 13, 14 until 18. So those are representative element ataupun main group elements. Okay, for example sodium. Okay, if this is the original electron condensed electron configuration for sodium. Okay, when it loses one of its electron, it becomes neon. Ataupun 1s2 to s. This is in condensed form lah. This is in condensed form. Okay. Or alternatively, you can also have 1s2, 2s2, 2p6. So this is the electronic configuration for sodium plus, or it can be written as neon in condensed form. Okay, and then we have calcium. So this is how calcium 2 plus, this is the condensed one. Okay, aluminium 3 plus. This is for cation. So cation, dia remove the electron to achieve an outer electron configuration as the previous noble gas. Okay, why? Remember dia nak become octet kan? So dia punya reference, dia punya inspiration dia siapa? Group 18. Okay, group 18 like hydrogen from group 1. Hydrogen want to become like helium. Okay, itu inspirasi dia nak jadi helium because when they become helium, they become stable. Okay, so it can either accept electron or it can remove all of its electrons because dia ada satu je elektron kan. Either way, they accept ataupun they buang, they still stable. Okay, hydrogen. That's why hydrogen can become H minus and also H plus. Okay, that would be for cation. So we have two types of ions, right? So we have cation and anion. So anions obviously, okay, atoms that gain electron to achieve an outer electron configuration as the next noble gas. Because kenapa dia nak achieve the electron configuration as the net noble gas? Because the octet. Okay, in short kita panggil dia octet lah, tapi when we talk about electron configuration, maksudnya in detail, we know what are the sub levels that we need to fulfill in order to become the next noble gas. Okay, the next noble gas, next for the anion dia kena tambah electron in order to become next noble gas. But for cation dia buang electron. Remember, dia buang electron in order to become the previous noble gas, so that it achieve the electron configuration as the previous noble gas. Dia kena buang electron. Okay, and ion on the other hand, dia kena add in electron to become the next noble gas. For example, 1s1 is for hydrogen. Bila dia add in electron, okay, gains electron, it become helium. Helium is the next noble gas. After hydrogen, we have helium. Same goes for fluorine. So this is the original electronic configuration for fluorine atom. Okay, when it accepts electron, it become neon. Dia nak jadi macam neon. Dia tak nak jadi macam previous noble gas. Dia tak mau, dia nak jadi macam neon. That's why dia punya ni adalah neon. Okay, dia punya reference will be, dia punya electron configuration, the noble gas is neon. Oxygen, okay, it accepts 2 electron to become again neon. Nitrogen it accepts 3 electron in order to become neon. Okay, right. So for anions, basically we have halogens and chalcogen. Halogen come from group 17, chalcogen come from group 16. So for halogen, okay, it requires 1 more electron in order to attain the electronic configuration of the noble gas. It needs 1 more electron. Dia 17 kan? So in order to do that, it needs to accept 1 more electron, and by doing so, it will have a negative 1 charge. Okay. On the other hand, chalcogen, group 16, it requires 2 more electron, okay, in order to attain the electronic configuration of the next noble gas. So in order to do so, it requires 2 electron, and the charge will become negative 2 charge. Okay. Chalcogen, chalcogen. So cation sama juga. Okay, so an ion have to accept electron. Cation on the other hand has to remove the electron. Okay, so we have alkaline metal and alkaline earth metal, group 1 and group 2. So these two tend to lose 1 and 2 electron respectively. Kenapa nak remove the electrons? Okay, in order to attain the electronic configuration of the previous, dia nak jadi macam previous noble gas. Okay, so sodium will remove 1 of its electron to become sodium plus. So so once it becomes sodium plus, they achieve the neon electronic configuration. Okay, magnesium too. In order to become like neon, it has to remove 2 of its electron. Okay. Transition metal, lagi sekali transition metal. Okay, this sikit special dekat situ sebab takut ada confusion. Okay, so transition metal, electrons are always removed first from the ns orbital and then followed by the n-1d orbital. Remember, contohnya. Okay, this is how, for example, the electronic configuration for transition element lah, for S2 3D2 maybe. Okay, for S2 3D2, the partial orbit, partial electronic configuration. Okay, we know that to remove electrons, to become cation, the electron need to be removed, betul tak? Kena remove the electron from the atoms. Okay, bila nak remove the atom, okay, in order to remove the electron, okay, the electron need to be removed from the outermost shell. Sebab apa? Sebab that it would be the easiest lah. Yang paling luar, sebab kita nak buang elektron. We need to remove from the outermost shell. Sebab itu yang paling senang. Rather than kita nak pergi tarik yang elektron-elektron yang dekat dalam tu. Okay, so that's the logic behind it. So for transition metal, okay, the electron will be removed. Okay, my question would be, based on that understanding, we will remove from the outermost shell, yang paling luar sekali. Okay, so based on what we have, the partial electron configuration here, okay, where would the electron be removed from? Is it from 4s or is it from 3D?
3D.
Any other question than the any other answer than the 3D? Maybe you choose, anybody would go for 4, n is equal to 4? Ada tak ke semua semua cakap 3D?
Both?
Both. Dia bila dia nak buang elektron tu, okay, dia kena step by step. Dia macam nak masukkan elektron lah. When you want to occupy the electron, you need to fill up one by one dulu kan. Dia tak selepuk masuk dalam tu, dia masukkan satu-satu dulu. Okay, same goes to removal of electrons in the atoms kan. Kena buang satu-satu dulu. So kena ikut step lah kan. Nak bagi senang faham ni, walaupun sebenarnya dalam atom tu dia dah siap-siap dah tersusun macam tu. Tapi dia akan buang, okay, it shall be removed from 4s ke 3D? Yang mana dulu?
4S.
4S.
Alright, so ada mix of answer dekat situ lah. So ada yang cakap 4S, ada yang cakap 3D dekat situ. Okay, tadi kan dah cakap kena buang yang paling luar. Okay, alright. So even though, so jangan confuse. Okay, bila you nak fill up electron, you need to be based on afbau. Afbau kata apa? Kena isi based on energy level. So whatever you have in the electron configuration tu, dia based on energy level from the lowest to the highest. But we cannot deny that the outermost yang paling luar adalah N sama dengan 4. Cumanya, in terms of energy, 4S has lower energy than the 3D. In terms of energy, kita cakap in terms of energy. Yang afbau tu yang ditunjuk daripada atas bawah tu, itu in terms of energy. But in terms of dia paling luar dengan dalam, it will be the highest N. N is equal to 4 is the outermost shell. Okay, that is why dia akan keluar daripada N is equal to 4. Okay, once all the electron in the 4s has been removed, dia kena buang lagi elektron, that means barulah dia remove from the 3D. D dah habis, then only it will go for P and yang dalam tu lah. Kena ikut urutan. Sebab yang paling luar paling senang nak remove. Sebab dia yang paling, you imagine you ada pintu kan, you nak tarik orang dekat dalam satu bilik tu, you akan tarik orang yang paling jauh dengan you ke atau paling dekat? Mestilah paling dekat dengan you, yang dekat dengan exit tu. You dekat exit, dekat pintu kan. Okay, you nak tarik orang yang far from you or the one that closer to you? Of course yang you closer to you kan. You akan tarik tu, nak tanya soalan ke, dekat mana bilik ni ke, you would go for the closest one. You tak akan pergi yang jauh tu sebab banyak kerja, you kena pergi masuk dekat dalam tu, you nak kena maybe you nak kena mingle orang tengok you semua whatsoever kan. So menggunakan that analogy, okay, that's the reason why bila nak remove electron, we would go for the outermost shell rather than the inner shell. But inner tu susah lah. Okay, and then there's one thing that you have to consider. There's an attraction between electrons and the nucleus. Nucleus tu, dia pegang electrons tu tau, dia macam anak dia lah kan. Dia attracts the electron because we know that nucleus is positively charged. Electron is negatively charged. So both of them are having different charge. So different charge ataupun opposite charge attracts. So they attracts very tightly, maksudnya kuat. So yang dekat dalam tu, all the inner electrons tu, dia tertarik kepada, dia attracted to the nucleus. So it's not easy to remove them out. So lagi dekat dia dengan nucleus, lagi susah nak remove. Okay, the further it is from the nucleus, by right lagi senang nak keluarkan dia. Okay, alright. So that is what it meant by this statement kat situ. Okay, ni just nak tunjuk positive one. Nak cakap positive one, group one, you know, so all the group one should have positive one charge. All the group 2's element, okay, should have positive 2 charge. 13, so that it become 3 plus. 17 is negative 1, okay. Group 16 negative 2, okay, and 15 we have negative 3. Alright, so this is an example. Saya pun tak tahulah, setiap kali dia mesti bagi macam statement tu awal. So saya kena explain awal. But one good thing is bila dia kena explain awal, bila next when it comes to the explanation of how the electron being removed for transition metal, you ada 2 kali explanation guys tu. Okay, so you akan lebih faham lah patutnya. Expectation lebih faham. Tapi ada je kemungkinan you tak faham. Lagi teruk tak faham. Okay? Okay. Alright, so now let's look at on how the electron being removed for transition metal. Yang isu yang tadi tu. Okay? Transition metal. Okay, iron. Iron come from transition group elements ataupun the D block element. So how do we know that it come from the D block element ataupun the transition element? Because it ends with D orbital there. It ends with D orbital. Okay, so 3D6. So this is the electronic configuration of iron, the original one. Okay, this is the orbital diagram for the condensed orbital diagram for iron atom. For S2, 3D5. 3D6. Okay, alright. So we know that iron can form iron 2 plus cation and iron 3 plus cation. Dia ada 2 possibility dekat situ. Alright. So for iron 2 plus, okay, obviously there are 2 electrons that need to be removed from iron atom. Okay, so how do we remove the 2 electron? Dekat banyak-banyak electron configuration ni, so how do we remove that? Okay, so please remember that the 2 electron will be removed from the 4s dulu. Okay, ingat yang ini dia based on energy, the arrangement is based on energy level. Maksudnya the energy lah, energy based on energy level lah. Okay, 4s2 has lower energy than the 3d2. Tapi bila when you want to remove the electron, dia kena buang daripada outermost shell. Okay, that's why bila as you can see, nampak tak dah kena buang. First loses its valence electron from 4s orbital. Okay, so sebenarnya kat sini ada 4s tu dia dah jadi 0, 4s0. So might as well tak payah tunjuk lah. Dia dah jadi 4s0. So see, 4s0. So this is Fe2 plus cation. Okay, when one more electron need to be removed, nak jadikan dia iron 3 plus, next dia kena remove dekat mana? Okay, so once the 4s electron has been removed, dah habis lah 2 electron kena buang, dia kena buang kepada next orbital would be the 3D lah. Okay, 3D. Dia akan buang dekat 3D. So the red one here is remove. Okay, so ini nampak tak dia punya keadaan dia tu. So this is what we call half fill. That is why iron 3 plus ion is more stable than iron 2 plus ion. Okay, so faham ya? Maksudnya especially for the D orbital, for the transition metal, it need to be removed from the 4s, from the s orbital first, then only the D orbital. Okay, alright, boleh try out for B and C guys. B and C, cuba try B and C. Condensed electron configuration. Nak hujan. Gelap. Alright, okay guys. Okay, let's try to solve for B. Okay, write the condensed electron configuration of the following ions. Okay, before we could write the what we call the electron configuration for the ions, we need to start from the atom itself. Kena start from atom dulu. Baru boleh kita imagine, oh the electron ni kena buang dekat mana. Okay, kena buang from 4s or 3D, or maybe we have main group element, that means kita kena buang dekat S ke ataupun P. Okay, so in order to get a clear view on that, it's best for you to start with the electronic configuration of the atom itself. For chromium dulu. Okay, so let's start with chromium. Okay, kita nak cepat sikit, kita buat condense terus lah. So chromium, the noble gas would be argon. Betul tak? Argon. So the Z is 24, okay? So this Z is actually representing the atomic number for chromium tau. Okay? Z is the atomic number or the proton number. This is applicable for the atom. But we know that the atomic number for Cr3 plus is also 24. Sebab kita tahu ni adalah proton number, but in terms of electron number, it's not 24, okay? So it should be 24 minus 3, the electron number is equal to 21. Okay, alright, so let's start. Let's start with the atom itself. So we have 24 kan? So argon dah kata 18. And then 4s2, okay, 3D. This is 3D4 kan kalau ikut but chromium, remember chromium is anomalous. Betul tak? Chromium is anomalous. So sepatutnya this is what we expected, okay? Tapi sebenarnya dia macam ni. Argon 4s 1 3D 5. Okay, ingat ni anomalous ni. Dia bukan macam ini, dia begini. 4s1 3d5. Okay, so 3 of its electron will be removed. Okay, kalau kita nak draw the orbital diagram baru kita nampak sikit. 4s, so this is the 3d. Okay, you kena nampak the clear view maksudnya selalu orbital diagram memang is the best lah. You nampak everything. Okay, so 4s1 3d5. So to become chromium 3 plus, first kali dia kena remove from 4s. Keluar, get out. Okay, ni baru satu elektron. So dah habis dah. The 4s is now vacant ataupun empty. So we need 2 more electron to be removed. So next orbital would be, next sublevel would be the 3d. So 2 elektron lagi akan dibuang, keluar. Okay, alright. So 4s is now kosong. There's no electron in the 4s. Next will be, okay, so we have 3 electron. Tak kisahlah you nak buang dekat belakang ke, nak buang kat depan, doesn't matter. As long as it has 3 electrons in the orbital. Okay, sepatutnya kita kena buang kat belakang. Tapi tak apa, dia tak salah. Okay, so this is how it looks like. So sepatutnya it should be argon, so chromium 3 plus. Okay, the condensed electron configuration should be argon 3d3. Jawab soalan condensed electron configuration. This is just for us to nampak lah, okay, clear view on how the electron are being removed. So kita buat orbital diagram. P electron configuration, this is how it looks like. Okay, right. So sulfur, okay, initially the atom would be sulfur, atom Z is equal to 16 kan. Okay, so sulfur we have neon. Okay, neon catalyst 10 electron, so dia carbon 10, so next would be 3s2. Okay, 3s2 3p4. Okay, 3s2 3p4. Okay, when it become s2 minus, they accept electrons. So there are 2 additional electrons are now being accepted by S sulfur atom, becoming s2 minus. So it will become neon 3s2 3p6. Okay, if we were to use the orbital diagram, so 3s kan. So this is the original. Okay, when it accepts 2 electrons, so it become 3p. So 1, 2, 1, 2, 3, 4. This is the original one. Okay, this is the additional one. Ni yang kita saya bulatkan ni additional. Maksudnya come from outside. Okay, so this is S2 minus, this is sulfur atom. Right? Okay, alright, so I need 3 minutes. Okay, obviously kita tak akan masuk periodicity, tak akan masuk lah. Okay, ini satu cerita lain yang agak panjang dekat situ. But just to give you an overview of what is bunyi petir berdentum-dentum. Okay, what is periodicity? Okay, periodicity, okay, what we have learned tadi, okay, on how to locate the elements in the periodic table, how to determine the valence electron, to know the group, okay, to know the block of the elements come from, and then what else? To predict the electron being removed, okay, the sub level, and then basically all of that. Okay, next is periodicity. Periodicity is how we arrange, the behavior of the elements in the periodic table. Okay, periodicity explains on the behavior of elements in the periodic table. Okay, all right, we know that elements are arranged based on group and rows. Kita ada rows that represent the period and also groups. And group 1, group 2, group 13, 14, 15 and so on for the main group element. Okay, alright, so these are arranged based on that. So kita ada 3 criteria behavior yang we want to know, okay, for all the elements in the periodic table. Once kita nak tahu in terms of behavior of atomic size. Okay, and we also want to know in terms of ionization energy. And then we have electron affinity. Okay, and last but not least, we also have electronegativity. Okay, all right, so we want to know the trend, okay, across the period, okay, across the period from left to right and then down the group. What happened to the size of the element across the period? For example, the atomic size decrease, they become smaller. And going down the group, the size become larger. Okay, same goes to ionization energy. Ionization energy means the energy needed to remove electron from the atoms ataupun from the ion itself. Okay, so that is what it meant by ionization energy. So across the period, ionization energy increases or decreases? Okay, going down the group, is it increase or decrease? Same goes to electron affinity. Electron affinity adalah kesukaan towards electron, suka kepada electron. Okay, so across the period, electron affinity increases or decreases? Down the group, increases or decreases? And same goes to electronegativity. Okay, alright. Of course, in order to know the trend, okay, dia kena ada factors that affect this atomic size, ionization energy, electron affinity, and electronegativity. So what are the factors that you should know? Okay, in order to determine this behavior. So like I said earlier, saya dah cakap pasal attraction between the nucleus and the electrons itself. Okay, that is one of the factors that determines the behavior of the elements, okay, in across the period and also down the group, which will be covered later. Okay, so itulah periodicity. Nak tahu perangai ataupun behavior of the elements across the period ataupun going down the group. To periodicity. So we are going to cover all of this, okay, in tomorrow's lecture. Okay, right. So hopefully you guys can be prepared for this. Baca-bacalah sikit, okay, go through all the pre-recorded video saya upload tu untuk you guys go through. Bukan saya upload saja-saja je buat penat je saya upload, you guys tak go through. Alright, okay. I think that's all for today's lecture. Okay, any question related to our lecture just now before we end our session? Right, I think there's no question.